All right, I think we'll go ahead and get started. We'll let people trickle in as we get going, but we want to be cognizant of everyone's time. Happy Wednesday, everyone. We hope everyone is having a great week, and hope that you are planning right to stay cool with the heat wave that's coming through. Um, and so it's funny that this webinar is over solar heating when we're about to get a big wave of heat ourselves from the sun. So like I said, thanks everyone for joining. This webinar will be recorded and a follow-up email will be sent out later this week with the information. So don't worry about taking too many notes. But we wanted to, everyone that is in attendance today is muted to decrease the amount of background noise, but we definitely want this to be a discussion based. If you have questions, please send those in the chat box. And what I'm doing right now is I'm sending a chat to everyone so you can see where that chat box is. Now there is a, when you look at the chat box, there is a drop-down menu to who you can send that to. Now, if you put all participants, it'll go to everybody. If you do all panelists, it'll go to myself and the other speakers. Just make sure that it either says the host, all participants, or all panelists so that I can see that and get that question asked to our speakers. So I failed to mention, my name is Caleb Powell. I'm an environmental scientist with the Tennessee Department of Environment and Conservation, more specifically the Office of Sustainable Practices, where our Tennessee Sustainable Spirits program is housed. Now I'll stop talking, but if you have any questions or comments, please send those in the chat box, and I'll work on helping you out there. So without further ado, I'm going to pass it on over to the brains behind our Sustainable Spirits program, Mark Valencia.
Hi, thanks a lot, Caleb. I really appreciate it. I'd like to thank everybody for joining us here today. Again, my name is Mark Valencia. I'm with the Department of Environment and Conservation, Office of Sustainable Practices, and today we're going to be talking about some really exciting stuff in terms of harnessing the sun's energy for heating fluids. So it's something that's really, I'm not going to say it's a new idea, but there's some new innovations along with it, and I'm excited to learn more about it as well. This webinar is kind of hosted through us within TDEC and our Sustainable Spirits program. So I'm just going to do a quick little overview of the Sustainable Spirits program, and then we'll move on to the main subject. So within the Sustainable Practices, we oversee a lot of things that are not necessarily related to regulatory compliance. So our office is one of the very few divisions within TDEC that is non-regulated. So I like to say we're not in the business of telling anyone what to do. We're in the business of promoting and providing support on organizations and individuals who like to go above and beyond when it comes to environmental regulatory compliance. So this is the stuff that goes above and beyond that. So sustainability focused projects. So a lot of the things we oversee are the Get Food Smart program. We have the Governor's Environmental Stewardship Awards, so that those awards will be next week to announce winners who've been recognized as organizations who are doing great within the environment. We do a lot of other things like Tennessee Materials Marketplace, where we try to find a new home for byproducts of other manufacturing practices. On the community side of things, we oversee our radon program. We do a lot of environmental education. We have a grant program for used tires. And on the state institution side, we do a lot of things that's promoting sustainability within state institutions. So that's kind of a back of house group. Tennessee Sustainable Spirits is a voluntary program that assists wineries and wine growers, breweries, and distilleries in increasing sustainability by promoting best practices, providing technical assistance, and developing relationships. So these next few slides, I'm going to talk about how we do that within the Sustainable Spirits program. So some of the benefits of becoming a member within the Sustainable Spirits program is once you get into the program and you are a recognized member, you get free use of this beautiful logo we developed on the right of this slide. So any of our members are allowed to promote this, put it on packaging, put it on their buildings. Some of the stuff we do is we provide window clings. So they can provide it in front of their, their tap room or their storefront to show that they are a Sustainable Spirits member. So we have that unique branding. We do a lot of website recognition, so we have an interactive map that I encourage all of you to check out later today. And you can see a map of all our members and what they got going on, sustainably speaking. We like to do some technical assistance, so any member who's interested in pursuing any sustainable practices, we can provide some of that legwork for them, try to help them get to whatever goals they're looking to do when it comes to sustainability and improving upon what they're doing already. We have a vast resource of different topics on our website. So we have stuff for home brewers, we have stuff for individuals looking for sustainable producers and what to look for. We have resources for any organization who's interested on pursuing some of those topics of sustainability as well. These are some of the promotional items that we give to our members. So on the left, that is a bottle hanger. It's designed to hang over the neck of a bottle, whether it's a wine bottle, whiskey bottle, a beer bottle. And the unique thing about these bottle hangers are that they're printed on a compostable paper that is embedded with wildflower seeds. So whenever the individual takes home a bottle of whiskey and they have that bottle hanger, they don't have to necessarily just throw it in the trash. They can actually put it in their garden and produce something new out of it. The thing in the middle, that's our window cling. So that's what you can proudly display at your storefront or on a window. And on the bottom right, these are coasters that we give to our members as well. And these coasters are actually made of recycled tire rubber. So a lot of the promotional materials we do use, we like to have some uniqueness to it in which it benefits the environment or it lessens the impact on the environment. So membership is obtained through several different categories. I'll go into the next slide to discuss that, but we have a checklist. There's 49 elements to this checklist, and you have to meet a minimum of 25 items on this checklist. This covers, on this checklist, it covers, water conservation, air, water pollution, waste reduction. We like to include community topics as well, and I'll show you that in the next slide. To become a member, you must apply. So the application process is fairly simple. We have a single one-page application that just has your general information on it. In addition to that, you must submit that checklist that I just discussed. So you have to show that you're doing at least a minimum of 25 of those items, 25 of those 49 items listed. And you have to submit your annual utility data and production data. So we need last year's water bill, electric bill, and gas bill, and how much you produced. And the reason for that is we will actually normalize this data and produce a ratio so we can show you. For an example, we can show you it may take you 5 gallons of water to produce 1 gallon of beer, or it may take this many kilowatt hours of electricity to produce, a gallon of distilled liquor. And with this data, we can compare it to national and international averages that have been developed through other organizations, and we can kind of show you where you stand in line amongst your peers. And another reason for this is to establish a baseline. So in the future, you can see if that ratio is getting smaller based on maybe some practices that you implemented after we did this. And it's a great way to also look at your overhead. It's showing you exactly how much water it costs you, how much electricity it costs you to produce your products. So once we get all that data, that checklist and application, we will review all this information, we'll compile it and do some data analysis. We will also work with our Office of General Counsel within TDEC to make sure that an applicant isn't undergoing any issues within TDEC if they're having some regulatory issues. If they are, we will let them know that they can't be a member at that moment, but we can work closely with them to get them back into compliance, and we can have them work with whoever they need to work with within TDEC, and we can get them to the right people to get that worked out. We also have the Small Business Environmental Assistance Program, who within our division, that can also help smaller businesses for free with confidentiality, so they can't, I like to say, they're not in the business of snitching either like us. So I want to make sure we're very clear that we have zero regulatory control, but we can help you. Once we get all that information, you pass that background check, I will set up an on-site visit. I will go through your facility, and it's not that invasive. All I'm doing is a simple walkthrough to just verify some of those things on that checklist is actually going on. I may make some observations and take some notes. And with all that information, that data, that walkthrough, I will develop a sustainability report for the new member. And in this sustainability report, I'll give you that baseline data that we looked at. We can show you where you compare. We verify some of the things on there, but we also will list some recommendations. And again, these are recommendations. They're not mandatory at all. They're completely up to you if you want to pursue them, but the recommendations made are just ways to help to go even further, sustainably speaking, at your facility. And with that, we also provide that technical assistance. So if you ever want to pursue any of the recommendations we've made, we can help do some of that technical assistance for you to see what we can do to get you there. That report also comes with the acceptance. So that's when I send you an acceptance letter with that report and all that information. So this is a checklist. It's a little small to see, but there are 4 pages in total. So I just want to go through so you can see them. But they're broken down by the different topics of water, air, waste, energy, sourcing, community, and maintenance. So this is everything that's listed on that checklist. So what I like to do is just give this to you, let you walk through your facility, just do a quick little walkthrough, talk to your front of house people, your back of house people, and see what you got going on and just check them up on the list. And even if you're not at 25, I like to tell producers that with some minor changes, almost all of the time I can get you there, so we can work together to get you in that 25 minimum. So some of the next steps that we got going on for our program, we want to increase membership, so if anyone's ever interested, feel free to reach out to me anytime. I love talking about this program. I love talking about production just in general, so I like to geek out on that stuff. We are always looking for additional feedback from our members and our stakeholders, so we like to talk to organizations and our members to see how we can improve upon this program, what's working, what's not working, things like that. We love feedback. We're always looking for additional resources for members. So if anyone listening has some really interesting resources, I'd love to see it, take a look at it, and see if it's something we can share with our members as well and share on our website. Currently, we're actually developing value stream mapping. Value stream mapping is a way to go through your facility and pinpoint all of your energy taxes. So you can look at each process of your production and see where your big energy taxes are. So I think I have an example. So this is a quick little example, say, for brewing. So, at the left right there, you get your delivery. So getting that grain into storage, there may be an auger for that, some auger systems. There's some kind of electric motor. What we like to do is we want to look at that electric motor, get all the information on that tag, and actually, go down there and see how long it takes, how long you run that electric motor to get it to the next step. That's where we can determine how much electricity it's costing you at each step of the process. So that's kind of what this example is showing. Another good example is moving the grain from the storage to milling. So there's an electric motor possibly moving the grain to the mill, and then there's an electric motor running at the mill. So we want to check out each of those motors, see how long they're running for, and things like that. A really good, interesting example as well is in the mashing process. So now you got energy to heat up. So Bill may be able to show us ways we can reduce that gas that it takes to heat up that liquid. But what we're showing right here is, the gas that it takes to heat up your liquid for mashing in. There may be an electric motor mixing that mash, and then you have water. So we're going to try to look at all of those steps and processes to see how much energy is being used in each step of the process. That's all I have. I like to say we can hold questions on my part at the very end, so I want to get Bill as much time as he would like, and move on to his step or his part of this program. And I'm going to do a quick little intro of Bill, and then we'll start going. So William Guinea, or Bill, has more than 40 years of experience in the solar industry as a retailer, solar contractor, distributor, and manufacturer, and educator. Currently, Bill is the president of Arctic Solar Incorporated, a high-temperature solar thermal collector manufacturer in Jacksonville, Florida. Previously, Bill was the director of the solar heating and cooling business at Johnson Controls. He also served as the program director for global renewable energy development and program manager for the development of the PV and solar thermal business at JCI. Prior to JCI, he was the general manager of solar thermal at Duke Solar and Solar GenX Energy. Bill also was a consultant to the Florida Solar Energy Center at the University of Central Florida. He has an inactive solar contracting license in Florida and was founder of a solar distribution business with 3 branches in Florida, nominated for a World Energy Award a guide to free for-service solar water heating programs for Caribbean Electric Utilities business plan. Bill has previously been the primary solar thermal instructor for both the North Carolina and Florida Solar Energy Centers and provided training workshops throughout the Caribbean and Asia. Bill also chaired the entry-level solar thermal committee for NABCEP and has been active in many states' solar organizations. So Bill, I'm going to pass it on to you.
Thank you very much, gentlemen. I do appreciate the invitation to present to you all. But your program sounds outstanding. It's something that should be replicated in all states, no matter what the industries are. This is how you connect industries to the potential to save energy, reduce greenhouse gas emissions, and save money. So I'm going to talk about the solar heating applications for spirit producers. This would apply for basically any of them. It's a heavy lean toward the distillery side of the business, but wineries and breweries have much the same needs as far as heat goes. So I will also review the technologies briefly to talk about the application of the different solar technologies. So, the $16 million on energy was spent by distilleries in 2018. Unfortunately, COVID kind of put the squash on a lot of the craft brewers and craft distillers. Many of them I know that actually stopped producing alcohol and started making hand sanitizers. So that became a fairly decent business to fill in the gap when their spirit sales were down. One actually was even making CBD oil for marketing to users of that technology. So, we all know where the heat is being used, how it's used, and the importance of it. The advantage we've got today is we can produce enough heat to actually create steam today. So I've got different ideas about how heat should be used in facilities. Many of them are double jacketed pots with steam injection. It can also be done today with high temperature hot water rather than converting it to steam, which takes an additional 970 BTUs to do that. We can utilize high temperature hot water running through the pots, but that's going to be slow in coming because it's a radical change from a supplier standpoint. So this is just a simple diagram and schematic of the process where, generally we see economizers on scrubbing heat, waste heat, preheating water going into the boilers. From the boilers, it goes to create steam, depending on the pressure or bars of steam required for the facility. There'll be, in some cases, pressure reducing valves. So we'll see in some applications 200 PSI, others are going to be 15 PSI. So the distillery we have here in Jacksonville is using 15 PSI in their steam process. But I'll go into a little more detail on this to make it easier to understand. So this is a real world example. This facility, it's a large facility. They use 22,000 gallons of makeup water per day. So their groundwater temperature is 61 degrees. So they've got a compressor heat recovery, changing it from 61 to 77 degrees. So that's heat recovery stage number 1. They've got another deaerator heat exchanger, taking it from 77 to 104 degrees. So that would be heat recovery number 2. The 104 degrees can also be realized with a low temperature polymer solar collector. So it's feasible to have a hybrid solar system whereby you're combining the solar technologies with low, medium, and high temperature applications to be able to raise it from 104 degrees up to 180 degrees for the condensation tank. So this specific facility has makeup water of 60%, and they have a condensate return of 40%. So their condensate return is 203 degrees, obviously below steam temperatures. So when they combine that 60 and 40, they've got a condensate blended tank of about 189 degrees, which is good because they've recovered as much heat as feasible before it goes into their boiler, which is going to significantly reduce the amount of natural gas they're consuming. If you take groundwater temperature of 61 degrees and start dumping it into your condensate tank, obviously this temperature is going to be significantly lower, which means you're going to use that much more gas to be able to raise the temperature you need to create the steam. So everywhere you can find free waste energy, it's a significant and a low-cost solution to be able to preheat your water going into a boiler. Because the solar systems aren't cheap, there's obviously a capital cost to that, and the more you can reduce the size of the solar array to give you the production you need, obviously the better, the lower cost for the user. So this system, in order to raise the temperature up, was going to require 345 solar collectors. Because of space limitations, we could only use 288 in the calculations. So the watts per square meter is the actual daily energy produced at the site. And I actually got this information from the user that meters both their direct and their diffuse radiation, so we're able to come up with our average annual and our average daily watts per square meter of energy that's available. And what's important about that is the delivery temperature is dependent on the sun. So knowing what that average daily production is as far as watts per square meter or sunlight that's available is important to us. And we utilize tools like the Solar Advisor model from the National Renewable Energy Lab and PV watts to be able to capture the direct beam radiation available at the actual site. So we'll try to determine what the average daily energy is at the facility site to be able to do the calculations to determine how much we're going to need. So we know that the average energy per square meter is 5.96 kilowatts, and the efficiency is the efficiency of the solar collector. So at the higher temperatures, efficiency of the solar collector drops. As an example, on a flat plate, typical hot water heating collector, a copper 4x10 collector, it would start out at a high efficiency, and once it gets to around 140 to 160 degrees, its efficiency drops off significantly, which is the primary reason it was difficult to integrate solar thermal technologies into industrial process heating in the past. The XCPC that we manufacture will generate approximately 14 kilowatt per day, and we know the average per year of 5,000 kilowatts. So when we take the 288 collectors, multiply it times the amount of energy we've got, we come up with the 1.5 million kilowatt hours per year that can be generated by the solar collector, which is the equivalent of around 14 million BTUs. So that's a significant savings to the facility. And when you look at what the reduction in gas is, it's 6.7 million cubic feet in savings of natural gas in this application. So the bigger the distillery, obviously the larger the savings is going to be. And 288 collectors is a fairly large system. A budget for that is going to be somewhere around $600,000 for that system. But with the generous tax credits and some of the other incentives available by the states and the USDA, that return on investment can be fairly simple. So looking at a typical design of a solar thermal system today, it's not rocket science. It's very similar to a small residential system. The only difference with a commercial is it's bigger. bigger solar arrays, bigger pipes, bigger pumps. Other than that, the design stays the same. So there's not a lot of rocket science or variables in the actual design of a solar thermal system. So we're actually pulling the cold water out of the solar storage tank, sending it to the solar collectors. And in this case, we have 2 pumps in parallel. And the reason for that is if you lose a pump, you've still got 50% of your flow rate, so you're not stagnating your solar collectors, so you're still collecting heat energy, but not providing any overheating issues related to the solar array. Another option that we integrate into systems today is a heat rejection unit. So in the event the facility shuts down or they have reduced hours or maintenance issues, or the solar array starts to run too hot, we can actually start dumping heat to atmosphere. The exciting thing about this today is there's been a lot of progress on thermal energy storage. So we're looking at how we can take that excess heat today, put it into thermal energy storage, which will again reduce the amount of energy used during the operation hours. So it goes into a heat exchanger that is going into the solar storage tank. That solar storage tank then is sending it into the process. So the solar storage tank, the distillery we have here in Jacksonville, we're storing 300-degree water in it. And we're sending that 300-degree water to a coil in a boiler. And that coil then is producing the steam pounds per hour at 15 psi going into the facility. So again, the advantage of this type of a system is it's all proportional. So a large system is going to produce X, a small system is going to produce Y, but they're all going to be designed the same way. So we figure out what's best for the integration into the facility, what the budget can bear, and how much energy they want to generate with the solar array. My recommendation is generally we size systems between 50 and 70% of their daily load. We rarely, if ever, design a system for 100% of the daily requirements for hot water or steam. So this is the Forefathers distillery that we have here in Jacksonville, where we're actually using a cast iron boiler. There's no burner on it, and we're taking advantage of the coil that's up in the top of the water table that would typically be used for hot water production at the facility. And we're actually running the 300-degree water through that, creating, boiling the top of that water table and creating steam. We're injecting it directly into the main steam line. And the advantage that is the solar system is continuously running, so we're maintaining pressure on the steam line. When and if the production from the solar starts to reduce, then that pressure drops. His backup gas boilers will come out of idle and maintain the pressure in the steam line, so there's never a lack of steam in the system. And once the solar starts producing again and pressurizing that steam line, then the conventional gas boilers go back to an idle position. So in this case, we're using 2 120-gallon thermal storage tanks with coils in the bottom of the tank, and that's how we're transferring the heat from the solar array to the storage tanks. So it's, again, a very simple design, and it works very well. So on a larger system that I started showing earlier, I mentioned that he had 60% of his makeup water coming from the 2 heat recovery units that's generating the heat up to 104 degrees, and he's got 40% of his condensate return going into the condensate tank. So because of this large volume of water, we're only able to reach that 87 centigrade, and then we're at 102 going into his deaerator tank before it goes into his boilers. But the savings, again, is significant. I think this had a 3-year ROI on this project. And it's a very simple installation because we're just adding a heat exchanger to the cold water supply after the heat recovery before it goes in the condensate tank. So we're raising it from 40C to 82C to be able to blend in the condensate tank to be able to integrate that solar very easily. So as long as we know what the mechanical system looks like, we can generally sketch out an integration design. So the different technologies available today in the marketplace are low temperature collectors that we typically see for swimming pools. They're the polymer plastic pool panels. And I say pool panels, but they can be used for any application because it's a solar thermal product. So generally they're going to top out at about 105 degrees. And the reason that is that's the maximum temperature allowed for a spa. So that 105 is typically what they say is the maximum temperature. The medium collectors, the flat plate collectors, and evacuated tube technology that we typically see for home and light commercial water heating will be anywhere from 105 to 200 degrees, and I'm stretching it there. Generally, it's 160 at the max, but some of the evacuated tube technologies coming out of Asia now can produce higher temperatures. So, and then when we get to the high temperature applications, that's going to be between 180 degrees and 400 degrees F, which means that easily they can be utilized to make steam to be able to inject it into a system. So mid-temperature collectors, like I said, are glazed flat plate collectors, ICS tubes, which are integrated collector storage. They actually are storing water on the roof in larger tubes that are heated up during the day and transferred into the facility in the evenings, or the evacuated tube technology. And unfortunately, all evacuated tubes are made in China. It's the only place in the world that they're made right now. They were some being made in the EU, no, excuse me, in the United Kingdom, and that facility is shut down. So basically all evacuated tube collectors come from Asia. And we've got a lot of less than honorable solar companies in the United States that say their Chinese system is made in the USA, but that's absolutely wrong. So this is a commercial flat plate system. This is actually the headquarters at the Johnson Controls facility where I worked up in Milwaukee. So we utilize this solar array to heat the hot water for the Platinum campus, about 7 or 8 buildings at the JCI headquarters. So this is heat pipe technology. This is actually the city of Chicago. So these are our Chinese evacuated tubes that are running either a heat pipe or a wet absorber. I believe these were heat pipes that had a magic solution inside, which is a mix of water and glycol. And as it heats up, it runs into the top manifold. As they circulate cold water through that manifold, it scrubs the heat from all of these evacuated tubes and transfers it back into the building. It's generally a lower cost technology because it is imported from China, but there's still, I think, quite a bit of work to be done on that. We don't have really a good idea of how long they're supposed to last. So when we look here on the left, this green is where the swimming pools, the low temperature collector technology is utilized. And we look over on the right, and these are those tracking trough systems we see out in the desert Southwest. It's actually generating concentrated solar power. So they're power plants. I actually worked on a 64 megawatt plant outside Boulder City where we used the big tracking troughs and a steam turbine to make electricity. So the advantage we see today with some of the technologies coming to marketplace, both here and in Europe, are technologies that are filling the gap, that 100 to 200 degrees centigrade, being able to do these solutions that weren't feasible in the past. So I'm actually working on a desalination project myself with the US DOE. We were a semifinalist and working with Georgia Tech, Southern Company, and Lawrence Berkeley National Lab on a new desalination technology where we're going to clean up the blowdown water from a cooling tower at a gas power plant in Georgia. So this is what's remarkable today. You know, all these industrial applications, again, that weren't feasible in the past can be done today and can be done cost effectively. So the high temperature collectors are concentrating designs of troughs, some evacuated tubes, mirrored reflectors like we see out in the desert as well that are concentrating sunlight onto a receiver tube. All the heliostats track the sun and concentrate all that energy on generally a salt solution, a melted salt solution. You've got a cold tank and a hot tank. We see some double glaze collectors that come out of Europe that can handle higher temperatures, and the reason that double glazing, it's like a double glazed window. It prevents heat loss, so they're able to capture more heat inside their solar collector, and some even actually have a triple cover on them. But the key is that for every layer of glass, you're losing solar transmissivity. So sometimes it doesn't make sense to try to go up to some of these triple covers, even though the marketing companies say they're ideal, but really they're not. And these are most common on process heating and solar cooling systems as well, utilizing lithium bromide absorption chillers or ammonia chillers to be able to provide cooling. So we're working with a couple of companies now on dehumidification of some of these marijuana growing facilities around the country. Some of the indoor growing facilities today as well need to do a lot of dehumidification and cooling of their facilities to be able to keep buds and plants from rotting in the humidity. So the evacuated tube wet absorber is basically a copper or aluminum absorber inside an evacuated tube with a supply and return line circulating the fluid through it. Our technology, the XCPC, is a non-tracking technology. So we utilize non-imaging optics, which allows the sunlight to hit the reflector and concentrate all that sunlight onto the evacuated tube and the receiver inside the collector. So this is the forefathers distillery, and you can see it's not a very large system, and it's producing approximately 50 pounds of steam per hour. And again, it's just a simple, low-cost solution for a small craft distiller or brewery. Some of the other technologies is Absolicon that's making very good progress. It's coming out of Sweden. It's a tracking trough system, so it generally can be roof applied as well. There's a company out of Canada now that is marketing this technology here in the States. This Heliovios is basically a polymer bubble. It's like a tube that they fill up. It's got a polymer glazing on the outside, and the absorber runs through the middle. The Rackham facility here on the bottom right is what we call a micro trough. So they're a smaller trough system, not the big 20-foot troughs like we see at power plants. And these are used more for water heating and industrial process heat up to specific temperatures. So the linear Fresnel lenses are the mirrors that actually track the sun and concentrate the sunlight onto a receiver on the top. So that absorber tube up top collects all that light energy and focuses it on the receiver tube. Again, the issue is moving parts. So anytime you've got a solar thermal technology that has moving parts, you're going to have higher O&M costs. Here's the Absolicon collector. You can see it's also a tracking system. I'm not sure how their system operates yet because they still are fairly new in the market. So the collector and the installer, we have certifications for the collectors. We're required. It's like I've just recently changed our absorber design inside our tube, so I have to retest and recertify. It's required. I have to send the collector to Spain to get a new test because they're one of the few facilities that can test high temperature collectors. So it's going to have actual performance verification, so we know how much energy that will produce. It's verified, it's quality, and it's consumer protection as well. So the IRS requires the SRCC certifications to be able to utilize the federal tax credit. And so in North America, we have ICC, SRCC certification, so we end up with this certification stamp, which is critically important. We also have in Europe the Solar Key Mark, so it's a different standard. Obviously, the Europeans don't want the Americans in their marketplace, so they keep up in the standards to disqualify American producers, but now we're starting to see more cooperation because of the issue related to global climate change. So we're able now to be able to certify our collectors for sales in Europe as well, finally. So also the NABCEP, as he indicated, I chaired the entry-level committee, and this is a solar heating installer certification. Some states require NABCEP certification to utilize their incentives. So there's both photovoltaic certification and solar thermal installation certification. So basically what this does is just, again, give the market more confidence in the technology and the certification of the people that are installing the systems, that they know what they're doing. So we described the different collectors, the technologies and operating temperatures, the applications and the certifications of both for the technology, hardware, and for the installer. So that's it. Questions?
Thanks, Bill. Yeah, I've got 3 or 4 questions that have came in, so we'll take this time now to ask those. And if you saw something that you have a question about, make sure to send that in the chat box, and I'll make sure that we ask that and hopefully get it answered. So the first one that I am seeing right now, it says, I'd be curious to understand if there are any opportunities for integrating PV panels into some of these builds for also generating electricity. Are there any benefits to an integrated systems like that?
Well, there are some systems that are putting a plate behind the PV module and circulating fluid through it to reduce the temperature of the PV module and collect heat energy for use within the building. I get calls all the time about people that want to use solar thermal to generate electricity using an ORC or an organic Rankine cycle engine. And I got to tell you guys, I have never ever seen one that is cost effective. And there are a lot of guys out there building these heat engines thinking they've got the, cat's meow, and they're going to generate electricity with solar heat. But from my perspective, none of them are going to be cost effective. And the primary reason is those heat engines that are generating electricity have an efficiency of between 6, 8, 10, on the best day 12, but I'd have to see it to believe it. And when you've got a 12% efficiency in the engine and you're combining it with a 60% efficiency of a solar collector, the system efficiency drops like crazy. Pardon me. If you've got waste heat available that would be going to waste and you put it into an ORC, that's free heat. That potentially could be cost effective because you're capturing that heat from the stacks of a factory or boilers to be able to generate electricity. But as soon as you start to add solar to it, it really becomes, not cost effective at all.
Thank you. Let's see. I said, what's the first step to identifying if solar heating is something that is feasible at my facility?
Well, I can tell you it is feasible at your facility. All we need to know is how's your mechanical system designed, what your energy bills are, how much your gas you're paying per therm or per cubic meter for gas, and how much makeup water you're using, and what temperature you're operating at. So those are some of the parameters we need just to look at a project to be able to give you a preliminary design or a preliminary estimate of a system sizing. Again, you know, any of the solar contractors should be able to tell you what you need and how large of a system you need, and then you just determine how much of the solar fraction you want to pay for. You want to pay for 50% of your load, 70% of your load, or higher. So it's relatively simple process. So a simple facility audit, and it looks like you guys do a lot of that stuff already. So I would think that the checklist that Mark has available would be very beneficial and easy to do. Or I'll make sure he gets the information he needs to be able to distribute it to others to help them design the system.
Awesome. Yeah, another one came in. It says, are there any types of rebates or incentive programs out there to help with the cost of a solar thermal system?
Yes, currently we have a 26% federal investment tax credit. And unfortunately, Senator Manchin Deep Six, the clean energy bill that was moving through Congress, which would have increased the solar tax credit to 30%, and it would also apply to nonprofits, whereby if you don't have a tax liability, the Department of Treasury would issue a check for that amount, because not everybody has tax liabilities because either they've got, you know, equipment purchases or other things where they don't have a big tax burden. So that was a big unfortunate issue, but we're waiting to see what comes out of the president today on what executive orders he's going to put through. Another program that's available is the USDA Renewable Energy Grant, and they will grant up to 25% of the total system cost, the equipment, installation, everything. And it's a $250,000 maximum grant, but you've got to be in a designated rural area, which many of these facilities are.
Well, thanks for that information. I'm gonna dig a little bit deeper into that, and maybe for the follow-up email that we send out to everybody that registered for this, we can include some of that information.
Yeah, it's pretty simple too, because you just go to the USDA website, you know, for the energy grant, you put in your zip code, it'll tell you right then if you're eligible or not. And it's for small businesses. And I think small businesses are less than 500 employees. So most facilities will qualify for that if they're in a designated rural area.
Yeah, and it's actually great that you mentioned that. We've got a couple people attending from our Small Business Environmental Assistance Program here in Tennessee, so that'll be some a good resource for them to distribute, you know, information on to some of the small businesses that they help out. So
right, we used the USDA grant on a honey processing facility. We put in a 10 horsepower LPG boiler and a solar thermal array, and it was really nice because USDA paid for the 25% of the whole system, including his boiler.
Oh wow. Let's see, another question came in. It says, for the heating fluid, and then in parentheses, water, is there any water treatment required?
Generally, the solar collectors are not going to let you put just water through it. You can use water. I use water all the time, but I don't use processed water. So there'll always be a heat exchanger on the solar side. And the heat exchanger will be dependent on what type fluids the processed water is. But in the actual solar collector, we can use water. We can use a water glycol mix in Tennessee. That's definitely what you would be doing. They do make high temperature propylene glycol that's available for solar systems. And actually by code, it must be propylene glycol, not ethylene glycol. And you can also use thermal oil in the solar array as well when you're operating at very high temperatures.
And there was like I guess a second part to that question. It said, and is makeup required for water loss?
Well, not for the solar array because it'll be a closed pressurized system. So we'll actually fill it up with water glycol, and pressurize it to overcome the head in the piping. And that way we can use a small circulator to circulate the fluid that's under pressure in the solar collector. So that's generally how that's done. So there's no makeup water, there's no fluid loss from the solar array. The only makeup water would be for the condensate tank and what's actually being consumed by the facility.
All right, good information there. I think I've got one more question that I see. So we've still got about 5 or 6 more minutes before the webinar is over. So if you think of anything, send that into the chat box. This one's a fun one. It says, what's your quote-unquote favorite type of solar thermal collector? It says like best efficiency in your mind.
Well, you know, I had a really good job with Johnson Controls. I was a director. I even had covered parking, so I didn't have to clean snow off my car. And I left that to come here to manufacture this new advanced high temperature collector because I saw finally an opportunity to do something other than just heating water on houses, to be able to do real work for industrial process heating and solar cooling. So I'm very excited by the work I'm doing now. I've got a call with 3M in Europe. We got a call in from Poland that they're scrambling to find solutions because of the cutoff of Russian gas. So finally, we're able to offer people a solar thermal solution that can really have meaningful impact on producing process heat and reducing greenhouse gas emissions. So that's my favorite.
Awesome. All right, well, I'm not seeing any more questions coming through. Bill, I just wanted to say thank you so much for not only the years of work that you put into this topic, but just coming on here and trying to teach us a little bit more about the opportunity for solar heating, especially in the spirit industry. Like I mentioned before, this recording will be on our YouTube channel. So if you missed something or you want to go back and you know, learn a little bit more from what Bill said or from some of his slides on his presentation, you'll have access to that. I'll be sending a follow-up email later this week with the link to that and to any information that we covered. I'm going to try to jump onto the USDA website and get some information about that grant funding and all that kind of stuff. But once again, I just want to say thanks again, Bill. Thanks, Mark, for talking about our program here. And if you have any questions about the Tennessee Sustainable Spirits Program, reach out to Mark, reach out to myself. Well, we'd love to get your facility into the program.
Anytime. I appreciate the opportunity, and I'm absolutely totally willing to provide any assistance I can to your members or to you and your program.
Great. Thank you very much, Bill. And thank you, Caleb.
All right, guys. Have a safe day.
Y'all too, the same. Thank you.
Bye-bye.